Thank you for joining us today again, and I very much appreciate all of your energy to get up at 9 a.m., sit here after what happened last night. If I'm slightly wobbling around, I might still have some leftover alcohol in the blood, but a little bit of fortification won't hurt today. I'm Fred. I'm a custom engineer working for Microsoft. If the custom engineering gig, you're officially assigned to some field. For example, I'm infrastructure and security, which is kind of nice, but inside, in reality, we are fairly liberal about what engagements we pick, what topics we cover, and to everybody's surprise in the room, no doubt, I pick PowerShell. Lots of it, every day, which is fun. And there's one thing, when somebody in the world files a ticket with Microsoft, if the first-line support can't handle it, that gets escalated internally into the proper directions so that somebody more senior might be able to help with that. And as it happens, about once or twice per month, the following request ends up on my table. Now, where does this request come from? It's born of ignorance, of people literally being helpless, not knowing what to do. They read in the newspapers that there's a malware, there's bad actors using PowerShell to hack your environment. It's a danger, it's a risk, so they want to turn it off. This especially comes admittedly from the C-levels. And they read some tech paper because the CIO kind of wants to double in his old field. I mean, we all know CIO, classic acronym for career is over. It's a kind of bad fate that happens to a technician that gets promoted a few levels more than he would really be comfortable with. So whenever you can make the time, you try to read up to stay with the reality of your team. But given how busy your life is at that level, the chances are you're not going to be able to do that in full depth. So that's where we get this kind of request from. And yeah, we have to deal with that. So what can we tell them? The first thing I really try to tell them, you know what? Attackers might be using it, but actually it's your best chance. It is hands down the most secured language that we have, and at least coming from Microsoft running on Windows. And you're not going to get a better thing to automate your environment. And sometimes this table alone already wins the deal, which I totally did not steal from Lee Holmes. That said, often enough, they still say, hey, I still want to disable it. Which, leaves us with the next discussion point. When I try to secure an environment, I like to liken it to a castle or to my home, and the attackers are the burglars. So when I try to shut down PowerShell, what protection level actually would that get me? You see that's down there? That's the protection level. As we all know, burglars come at night. They go over your lawn, not the road, that might be booby-trapped. They might not see the stone, they might stumble over it and break a leg, and you might be secure from that. That's about the protective level you get from disabling PowerShell, because you just have to kind of look at the darknet and what offerings there. You can get attack packages fairly cheaply, and quite a few of them say, okay, I'm supporting 10 different attack languages, and if one of them is locked down, okay, then just take the other. And given all of these nice security features, especially in the logging, my opinion is, and my statement officially here, you should beg on your knees, you be grateful to all the attackers that are attacking you with PowerShell. It's kind of like, it's like Putin would be phoning in Zelensky and say, hey, tomorrow I'm going to attack there. Okay, or today, but this is my war plan, because they will be signaling everything they're doing. You just need to grab the data. So we're at the level of placing a stone. So that's the security game. It's better than not having a stone. It definitely worked out for my aunt, where that actual comparison comes from. She literally did have a burglar stumble over a stone. So, but I don't think we want to rely on being my aunt. That doesn't probably not work in repeat. So that's the advantage. I mean, it's better than nothing, but we might have some disadvantages when it comes to our ability to defend ourselves slightly. And at this point, some of them still say, I want to shut it down anyway. This discussion, even this picture doesn't move them. So at this point comes one of the most magnificent features I have from joining Microsoft. It is something that revitalizes me, something that refreshes me. It gives me so much energy. It's one of the absolutely most awesome features for me with Microsoft. I can say, sorry, not supported. Before that, I need to find some blog post, do some interpretation from the PowerShell team, tell them it's a bad idea. Now I can say, yeah, you can try to do that, but it is not supported. Every machine you shut down PowerShell on, which you can, but every machine you shut down is out of support. There's a very simple reason with that. Our entire Windows operating system team only tests their operating system with PowerShell turned on. The scenario of it being turned off is not being tested. And things would go wrong. I did do the testing because all of the maintenance tasks are running PowerShell. So if you disable it, your server is going to start developing problems. Okay, at that point, actually, I usually win. If I don't win the argument with that, then I kind of say, okay, then why are you raising a support ticket of Microsoft if you're not going to care about what we support? Yeah, so what do you do next? Now, there's one myth that comes in right next because that is something people actually hear about. Okay, if we can't shut it down, let's go with execution policy. A very common confusion is that people actually believe execution policy is a security feature. It is not. It has never been. It was never designed as a security feature. And there's this nice blog post, 15 ways to circumvent the execution policy. It's great. What is the execution policy? It was designed back in the days of 2008, where we thought, hey, there's this internet thing. Admins sometimes do stupid things, and we want them to think again if they just download a random script and try running it in the hope it solves their problem. Which execution policy, surprisingly enough, did not work very well at. As reality moved on, what really happened is that all of the code on the internet is being posted on blog posts and GitHub, and we just copy-paste the content in a local text file, and the execution policy doesn't realize it's a script from the internet. Yeah, and if you want to block everything, well, who can block if we do literally block everything? It still has its use if you're trying to implement code signing in your organization, because you can tell it only code signed scripts are allowed to run, and with that you can kind of bully your admins into signing the script and not working around the process. They can still do so, but for the admin it's annoying. It's never stopped an attacker, but admins will probably kind of follow the path of least resistance, and with that code signing might be the path of least resistance. So, if that's not the solution, what then can we do? Well, for the first thing, we can manage what PowerShell versions we have, because all of our nice and shiny security features don't work if the attacker is using a PowerShell version that is out of date and doesn't have those shiny and new features. Okay, not so new anymore, admittedly. Yeah. We also have this fun thing about us needing to prevent the use of older PowerShell versions. Question to the audience. Who of you has made sure that in your environment, older versions of PowerShell are uninstalled, that they are no longer on the machine? Now, yes, everything older than 5.1. Now, especially PowerShell version 2, you uninstall the feature, you make sure it's gone, and you're safe, right? No. Yeah, we'll be coming back to that, but you need a different way to disable it. We'll be looking at that. We control what code is being executed in the best way that we can do. We will look at how can we harden our remoting, and at the same time get rid of some of the myths that swirl around what you should be doing there and what's the actual effect of doing that, because there are some guidances and myths around, for example, requiring HTTPS for remoting. Looking at that. And finally, remember how I said that you should be thanking attackers for using PowerShell? That's because they tell us what they're doing, but we need to, well, kind of enable that and look at it, which is where logging comes in. Okay, chapter 1, PowerShell versions. If you've got an older version in Windows 10 and 2016, you can update that, use Windows Management Framework. Supported for everything other than if you're running Exchange 2016 on 2012 R2 operating system. For PowerShell Core, the new shiny PowerShell version, there is something we recently have managed. And if you remember from day one, the nice slides of PowerShell consumption going through the roof, with additional runs, operations being triggered, I'm fairly certain that integration into the Microsoft update cycle is the main reason we have that surge. Of that, you can literally deploy it using whatever package manager you use, SCCM, whatever, and get updates through WSUS or just straight Microsoft Update. There's one gotcha at the moment, and that is we only support that for 64 bits PowerShell, not for the x86 or 32 bits option. You've got a question? Okay. So with that, we can make sure we also don't accidentally drop out of support for PowerShell core versions. So that's nice. We've got that. So for that, I hope you forgive me for not doing a demo for how to update your PowerShell. Control code execution. How can we control what is being run? Traditionally, we have an approach for that, and it's called application whitelisting. We use AppLocker, Windows Defender Application Controller, whatever it's being called today. I mean, you know, the renaming thing of Microsoft. I didn't bother to look it up. It might be out of date tomorrow. So, yeah, we can whitelist applications, and that is where the main problem comes from when we're talking about blocking scripting engines, because the application happens to be powershell.exe or maybe pwsh.exe. Or maybe notepad.exe. By the way, if you catch somebody running PowerShell and Notepad, you probably have a problem in your environment. And yes, I have had that happen. The key thing that we need to remember is that actually PowerShell lives in system.management.automation.dll. And you can inject it into any process and run PowerShell, whether benignly or maliciously. Which, by the way, brings us back to you uninstalling PowerShell version 2 on the boxes has no effect. Because the attacker can just copy-paste the perfectly legally signed by Microsoft version of system.management.automation.dll in version 2 and run a script there. So what we need to do is you want to actually block all the versions of PowerShell. Is you need to block the binary, which you can do with a publisher rule because it is signed by Microsoft. So you're blocking system.management.automation.dll, the product, signed by Microsoft with the following version or lower. That's how you can actually prevent the attacker from shipping their own versions. So we don't actually have a process that we are trying to block. We're trying to block the individual file the process is executing. And a file we're trying to be executing? No, not so much. I can do, for example, just type my code on the console. I mean, most of us do this most of our work days. I can literally paste an entire script into the console. I can have it as a start parameter in PowerShell, so there's no even a file. I can just do an encoded command and provide 1,000 lines of code as a start parameter. Or I could spin up system.management.automation.dll in my .NET application and load the code straight into memory there. So in many cases, we don't have a file. And with that, file-based blocking is at a dead end. It's never going to work. We had application whitelisting support for PowerShell in PowerShell version 4 already. And if you did that there, it would block the script execution, but it would never provide the protection by just reading the file into memory and then executing the text as code. So in PowerShell version 4, that didn't really work as we had hoped for. And we have the same problem for antivirus software, not just for how can we prevent their execution, but how can we detect malware If you don't have a file to scan and you've got file signatures on your antivirus, the antivirus is not going to have so much fun in most modern attacking. For example, control and execution scheme, the client code is benign that they are executing in the Office macro, and they would receive their actual pay code using DNS queries by looking up text record of the actual malware code. Who amongst us is filtering DNS records? Yeah. So what we added is something called the anti-malware scan interface. We had a great talk on that. I think it was yesterday. If you didn't attend that, there's a recording. I can strongly recommend that if you want to see how exactly it works. But what it really happens behind the scene is we're submitting all the code, and any anti-malware service, antivirus can scan for it and tell you that this malware, don't execute it. So for some reason, Defender, for example, is quite prejudiced against invoke mimikatz. I wonder why. Now, there's two caveats about benefiting from AMSI, or anti-malware scan interface, and that is, first of all, it has a strict operating system requirement. Even if you install PowerShell 5.1 on your old servers, they don't get AMSI. Also, your old clients don't get AMSI. This is an operating system feature. And the other one is your antivirus needs to support this. If you have Defender, yes, it works. For some of the others, you will need to check with your vendor. Do they support it? Do you need to do anything to enable it? I know at least one software vendor that supports it, but you need to check one checkbox, otherwise you don't get it. Yeah, so that is how we can detect fairly reliably malicious actors, get alerts, get malware detection in your antivirus console. That's great. But at this point, the attacker was possibly still able to run some code. I mean, we might have been able to block it, but what if the attacker actually invented their own virus and we're hit by a 0-day and the signature just doesn't exist yet? The application whitelisting approach is, hey, only the thing that I'm allowing to run is allowed to run. So that has a great benefit. We don't need to know the actor as long as we know you're not one of us. And that would be great if you had that in PowerShell, but this problem is we're not file-based. You can only run this file approach doesn't work. So what can we do? We have something called constrained language mode, and if you engage application whitelisting of any kind, all PowerShell code will be run under this mode. AppLocker is an option. It's an easy to deploy, fast to go option. If you want a full security feature rather than just defense in depth, go for Windows Defender application control or equivalent things that actually work at the kernel level properly. But AppLocker is something you can deploy in a few minutes and get some protection out of it. Constrained language mode. That is the main feature that we have. What does it say? If our code is not trusted, you don't get all of the things PowerShell can do. For example, you can not call any .NET methods. Most properties are read-only on objects. Some commands may not work at all. For example, there's this nice command called enter PS host process that allows you to inject yourself into the PowerShell console of your coworker on the machine and then execute code in the context of your coworker who might be kind of peeved if you modify a domain admins group or take over global admin and you're a tenant in his name, but with your IDs behind that. And that doesn't work anymore when you have that enabled. You can't do PowerShell classes, you can't do a type, you don't have any direct access to the Windows APIs. We did a scan on all the known malware that we have in our Defender database that uses PowerShell. And more than 99.9% of all attacker scripts would not run in this mode. Yes?
Does PowerShell 7 support?
Yes. PowerShell 7 does also support constrained language mode. It applies the same rules and the same considerations. So if turning on application whitelisting actually enables constrained language mode, what about our own code? I mean, yes, it's nice we're blocking the attacker, but we probably don't want to block the official admin code. There are some ways to solve the problem. For example, you could explicitly whitelist any module stored on the C programs, program files, Windows PowerShell modules. Path whitelisting, any module that you're whitelisting, or if you've got code signing implemented, strongly recommend that. You can whitelist your signer certificate. If you do that, any code that is trusted is allowed to run uninhibited. Of course, that also means you need to make sure that an attacker cannot use your trusted code to turn untrusted code into trusted code. For example, if you're using invoke expression in your own trusted code and taking the input and then invoking it, you probably have the PowerShell equivalent of a SQL injection. Not all that great. Yeah. You can also affect, and that is the main deployment trick to get it deployed swiftly, you can exclude elevated processes from this. So it only applies to regular consoles. Very handy. And this is the next one. If you're writing PowerShell modules, even if you're whitelisting it, if you've got this nice functions to export wildcard thing going on because it's convenient, because it's easy, you will not have a great experience because whitelisted or not, PowerShell is going to tell you no. In order to ensure integrity, you cannot dot source a trusted script in an untrusted context, which, by the way, means you can never whitelist your PowerShell profile. Never. Because the profile is being dot sourced into the PowerShell process as it starts. What you would do instead is you put your profile as a content as a PowerShell module that you whitelist, and then in your untrusted profile, you import a module. All right, enough talking. Let's take a look at how we do this. Now, the first thing we need is something that actually gives us a level of operability when we define the rules. We don't want to handcraft everything, and there is a tool by a certain guy called Aaron Margozis called Aaron Locker. He's moved on from Microsoft, was a security architect previously, and well, he did a scanning tool that will take a reference machine and scan it for configuration, and then generate a policy set to, well, secure a machine, including PowerShell rules. For that, let's start a PowerShell process in the folder. And all we need from that solution is the create policies command. It is now scanning the machine and generating proper. Damn it. The demo god still got me. I really should not have taunted them. Do I have that lying around? I don't, so I'm going to swiftly steal that from my most trusted automated lab solution, which in lab sources has tools, sysinternals, and there's the access check right there. Thank you, Raymond. So let's try this again with less red stuff. Okay. When you do path whitelisting, we do have a habit of C Windows and C program files are going to be safe, right? Actually, under C Windows, there are quite a few folders users are allowed to write, and we need to have an exemption for that, because if you just whitelist Windows folder, you could, for example, use the folder used for spooling tasks to just create your file there and run it from there, and it's whitelisted. Not a good choice. So we have that. Now we need a gpmc.msc. And let's say I want my servers to be subject to to constraint language mode here. Yes, I know this is only a link and I'm going to edit it anyway. Edit. Where the hell was that? Under security settings, we have lots of information, and one of them is the application control policies, which is AppLocker. For that, we can now import a policy file if we have one at hand. which we have here in the outputs. We have two policies. One of them is audit, the other is enforce. If you use the audit policy, you get warnings in the event log, but it does not actually enforce anything. So if you want to get your feedback, see what would happen if I turn this on, you use the audit policy and you just get warnings and you can plan for the migration if somebody would actually be stopped by that. Okay, we need to import a policy. I'm going to go to that folder, grab the... let's go with enforcement. I mean, what could possibly go wrong? Yep, I want to import that. None were removed, 95 were added, and we now have app locker policies. For example, we have now a disallow PowerShell version 2 rule in here, pre-configured for us, which when we look inside is a publisher rule with the publisher, product name, file name, and the specific version we're requiring. And with that, all older versions of PowerShell are blocked, whether it's the built-in one or somebody ships it in. Piece of warning, if you're supporting SQL servers, they've got a PowerShell agent, and depending on the SQL Server agent, that PowerShell version is lower than 5.1. So you might accidentally block a SQL Server automation. All right, with all that, we now have, amongst other things, script rules with the various paths that are explicitly whitelisted, including the Windows folder, which has exceptions for all of the files that actually users can write to. Freshly scanned, if you've got a modified device, it's going to pick that up. So you pick one representative machine, and that's it. The other thing we need to do is enable one certain service and make sure it's running. So where do I need to go for that? Not that, it's in control panel settings. Services, new service, and the service that we need is the app ID service, which absolutely should be started, and it needs to be automatic. If you don't run that service, that is what actually passes through the app locker rule to the system and enforces it. It doesn't work, which, by the way, is the absolute proof, in case you're wondering, that app locker is not a security feature, but a defense in depth feature, because anybody who gains local admin can simply turn off that service or inject their own whitelist everything rule and keep the service running to avoid the signals. All right. That said, how does execution policy, the constrained language mode, actually limit our coding? System, less typos thread, and it actually might work. It's still optimistic, but maybe I can actually, yes. So let's resolve localhost and see what it's going to do. It works just fine. If you want to check your current language mode, you can do that with the $execution context, session state, language mode. So I'm in full language mode. I can do whatever I want on the machine, as long as I've got the necessary privileges, actually, but the language features are not disabled in any way. So I'm just going to, for this demo, because I don't want to actually wait for a group policy application to properly work the service and everything, I can actually enforce constrained language mode if I actually, don't forget the language part. No? What did I miss up that? Yeah, without the mode. All right, we are now locked down, and if I now try to do the resolve thing, that's the error that I get. Yeah, I've locked down the process, and every new process that I start is going to be affected by this, as long as the user's temp folder is locked down by the policy. If you whitelist the temp folder, the console will not go into constrained language mode. So let's fix that.
Would code signing go around that language?
Code signing would go around that as long as the policy is applied. So if I had the GP update applied, app-ID service running and everything. I try to run the file. The file would not be in constrained language mode if I have that signed by a trusted certificate that is whitelisted by a rule. It's not enough to just be trusted, it needs to be whitelisted. So let's go back to full language. Yeah. No. Constrained language mode, I can't write to any properties anymore, so bootstrapping me back into full language mode is a losing game. So let's kill the console, and the reason I actually try to not lock myself down is because I need to run a few more samples. Let's say we are planning this whole thing out, we're talking with teams, and they are kind of wondering, will our code be affected by constrained language mode? I mean, we've got a huge code base, and which of these scripts might be at risk? You can enable the auditing and see where the error events happen, but wouldn't it be kind of useful to have a scanner to do this for you? So let's take a look at this nice script. It's a script I wrote for figuring out AD delegation and writing the results somewhere. This is usual working script. Let's see how that would be affected. Nope. I need this in a size you folks can actually follow, and I think size 14 is not the answer to that. Okay, it's not going to work here, but there's a module called PS Module Development. It's my personal development toolkit, templating, refactoring, .NET searching, restarting my console as admin, whatever I really need. And it also includes a certain command. Okay, no, that didn't work out. It has a test PSMD CLM compatibility. Test PSMD CLM compatibility command. And with that, I can specify the path and it's complain about every single thing that's going to go wrong if you run this in non-compat mode. All right, damn it. Totally hitting this, getting cut down by having less time for the whole thing. I think right here, sorry about the scheduling issues. I'm going to have to skip a few of the next demos because I need to cover a few more things. You probably have some questions and we only have so much time. So I have to skip the other demos for that. When we try to configure remoting, how can we make our system safe? The group policy settings are clearly separated between server and client. That is not the operating system reference. The client is the source of the connection. The server is the recipient of the connection, no matter what this does. We can configure where we want to accept accessions from using the firewall. There's a setting, enable PowerShell remoting, and then you can specify an IP range. This is not where you're accepting sessions from. This is a filter to your local network adapters. On which network adapter do you want to receive the connection on? So that is why wildcard is the usual recommendation there, because it just means every network adapter and that's it. You want to filter that if you, for example, you've got a machine that has a public interface and a management interface and you only want to accept connections from the management interface. And we have authentication options. That's like, for example, do you allow basic authentication? The basic authentication thing is one of the classic myths that we encounter, specifically for Exchange Online admins and people that have to go work with the Security Compliance Center module. Because if you wanted to administrate Exchange Online, you would be forced to enable basic authentication for the client. Now, when a security admin hears basic authentication, that's like are you trying to ritually sacrifice my child? What the hell are you trying to do here? Basic authentication, that was in the 90s maybe. Why would you do basic authentication? Well, turns out that the WinRM service that is operating the connection has no concept of modern auth. So if you put enable basic authentication, put some network trace in there, what Exchange Online module and the others did is they would first do modern auth against Azure AD and the basic authentication would actually be the token. So you're doing modern authentication, the service just has no way to detect that. So that's why I did that. There is one important thing for all of the security folks out there. In PowerShell, you cannot force anybody to do basic authentication from the server side. You can't trick them into a downgrade attack to use a less secure protocol, to send an unencrypted password. You can't do that. The user needs to explicitly request that. So allowing from the client side the basic authentication does not actually incur any additional risk unless you've got somebody who's trying to force it. You can also mess with the network settings. For example, you can tell it you must use HTTPS for your connection. If you do that, you get absolute security, obviously, because you know HTTP by default, so PowerShell is working unencrypted. No, we just don't do transport level encryption. It's if you've got a default domain, you've got IAS 256 through Kerberos communication, so we do encrypt the packets. The only real safety you get when you enable HTTPS is if somebody has a reason to use anti-LM authentication, because in anti-LM the client does not authenticate the server. And that you can do with the certificate. But that's the only security you get here. So it's only relevant if you still use anti-LM authentication for something. And big surprise, managing the certificates is kind of annoying because the auto-enrollment and auto-registering in WinRM doesn't really happen, so you have to manage that as well. So you get administrative overhead. The security gain is very situational. Yeah, I could show you the configuration options and how that. I will add the exported policies on all of the settings that you're seeing in the materials when it's on the GitHub for looking them up. But I think seeing me operate the group policy console is not going to add much to the session. So we're skipping that. Which leaves us with logging. In PowerShell, we have 3 separate logging options. We can do transcript logging, which we can do since the age of PowerShell 2. We've got module logging since the age of PowerShell 4. And we have script log logging, which we have since PowerShell 5. Transcript has the nice advantage that it actually shows also what have been on screen, which is great for debugging purposes. It's not so great from a security perspective because A, you need to do log rotation. B, it's clear text. C, somebody might have accidentally leaked something sensitive on the console screen, which previously was not noticed, but now is in clear text, unencrypted text file on the screen. Or you might have some privacy concerns if you've got a user actually using PowerShell for his online banking. I mean, I haven't seen that, but I wouldn't exclude the possibility. So a transcript logging, I strongly advise against that as a global security feature. You can do that for your actual logging in a script. I would like to talk to you about PS Framework if you do. But module logging is, well, the lesser brother of script log logging, so I really just recommend going with script log logging, which will give you the same information in the event log as the AMSI gets, so you get a full script log, that's every code that's being run. If you enable that, you still need to ship the logs somewhere, so yeah. Handling that is a bit of the hard part. You still need to analyze that, and there is not all that much aid that you can get from Microsoft from that so far. So we just say, hey, do the logging and do whatever you think you need to do the detection afterwards. I'm currently working on a module to help you with that, to help analyze what script is running on which machine, so you can do pattern detection. For example, the maintenance script that every client is running. And so you can see, can identify known scripts and identify unknown scripts and then start investigating on that. But that's not quite done. But I will definitely be announcing that on Twitter once it's ready. Yeah, there are a few other things we can do. That's just a quick checklist. I'm definitely not going to demo that here because that is entirely separate talks to have. There's another 2 hours session just on how to do properly released thing. But you want to look into how to release your own code and how to accept foreign code. So you can actually safely use public modules, which includes code signing and internal source control. And if you've never used it, there's a just enough administration. It's a PowerShell remoting feature that allows you to delegate individual processes rather than control over the entire system. Scenario, help desk, terminal servers. Help desk, with GI, you could authorize a help desk user to send a message to the user, figure out who's logged on, and turn off sessions that are hanging, but not anything else. If you don't use chair, you basically have to construct your own constructor, give them local admin on each terminal server, which, let's be honest, I don't want to do with help desk users, mostly. Final slide, then you're done with the PowerPoint mess. Sorry about that. About the rush. Now that we've got a lot of features, but how do we actually implement it? How do we go about bringing this into realities? There's a recommendation there. I strongly recommend that you nail down the remoting. Just if you've got only allow PowerShell remote connection from an admin network, because users really don't have a reason to connect to each other with PowerShell remoting. That would solve a lot of the lateral movement from client to client. The hardship here is you, of course, need to have a network, an administrative network to identify, which might be a not quite as trivial process than just setting out some firewall rules. The other one I recommend is doing app locker in user mode. So you only affect non-admin processes and deploy constrained language mode. This actually can be done in 5 minutes and massively impacts what an attacker can do in the user mode on an affected client. And it usually has absolutely no side effects on regular processes. The logging, enabling it is fast, managing it and getting useful action is a process that's going to be ongoing. So that's not something swiftly done over, it's more something you put into as part of your risk management process. And finally, you want to have internal code management, you want to have internal approval process for external modules, you want to have a way to centralize this so you can share that with other teams so you don't have that redundancy inside of your organization, because it's a fairly expensive process to actually approve external code because you have to do the review. And the last one is one I must admit I've never managed to establish fully in an environment, that we have a full hard enforcement that only whitelisted code, only approved code for the process, only that is code signed, can be used internally. Because that really requires all of the other processes to already be in place. That said, there is one more advice that incredibly helps with adoption. As soon as you possibly can, get your admins to use source control. Even if it's just so they have an online version of their code, so they have a master version that is the true copy of their script. They don't even have to share that with their coworkers. But a lot of the advanced workflows are only possible if you already use source control for getting a code signing pipeline, for getting a proper approval process. And if you also have to now start teaching your admins at the same time the tools needed, you get a lot of internal resistance to all of the change you're forcing on them. If you start them off with source control just for, having backup of the tool, having in case the client crashes, having a central location, that's something you can do swiftly and they can already get used to the tools, so they only have to master the new process later on. Otherwise, I've had at least 2 projects basically stop at that stage simply because the admins rejected having to master the tools and the process and everything because it was one large package. Thank you, everybody. Now it's a bit less time for that than I really hoped for, but any questions?
You said PowerShell 7 can patch by Microsoft update.
Yes.
Can it patch by WSUS?
Can PowerShell 7 be updated through WSUS? Yes, it can. Yes. Again, only 64-bit, not 32-bit. Yes?
How to allow developers to develop code with PowerShell ISE while in constrained language mode?
I would do individual exemption for those. The developer machines, basically give them a machine, a virtual machine or VDI environment in a test environment where they cannot corrupt the organization.
Follow-up question for PowerShell 7.2 update while WSUS. I tried this and it's not working at the moment, or Because I also asked Sydney about this, and she said she's not quite sure. She has checked with her team.
It used to work in my lab environment right after the announcement when I tried it, but I don't know whether it's broken again in the current state. I have to look that up in the, and also have to, well, set up a lab for that and iterate that through. But yes.
Talking about code signing, how do you handle like SCCM agents that have scripts with unsigned code?
Okay, how do we handle SCCM clients with unsigned code? The SCCM client has a dedicated folder where they're putting their code before they're executing it, the script code. You whitelist that path. It is a path where only the system has write access to by default, which you should, of course, be monitoring for whether somebody managed to modify that. But you can do a path whitelist to solve most of those problems. Also, to make sure you actually catch that, you can also do two more things. One, most of the SCCM agent scripts are run as administrator. So as long as you only do the non-admins are affected rule, those agent tasks will not be affected. The second part is you could also and should do an initial audit mode and just check for whether they would be affected. In the event log, you see where the file would have been, so you can analyze an automatic filter for warnings about app blocker or similar blocking them for that SCCM folder path. That's another way to handle the SCCM client thing. One more question?
Regarding the PowerShell logging.
Yes?
When I open the console and I type in some commands, and then I close it and reopen it and press the cursor up key, it shows me the last command that I typed. Is this logging or is this merely the history?
That is not part of the security feature of script block logging or anything like that. It's the PowerShell module called PSReadline, which maintains an input history in your app data folder. You can grab the path for that. Let me do that one real quick. That is fast to do. So get PS read line option. You can see the path where it's saving your history here. It is merely your input history. It tries to filter to avoid secrets. But if you do like $P equals quote clear text password quote, you're not giving PSReadline much to work with. So if you accidentally leak a secret there, you might want to check that file, whether it's in there. You can just delete it. You can also disable it by setting the history save style to none. All right, we are already over time, and I kind of probably should vacate the place here. If you've got any more follow-up question, you can find me across the conference floor. Getting me to talk about PowerShell is probably going to be one of the least difficult tasks you will be facing here.